Hello everyone. In this video, we will continue to examine topic 9.4 resolution, and in particular, solving problems involving the Rayleigh criterion for light emitted by two sources diffracted at a single slit. In the last video, we defined the Rayleigh criterion, which, as a reminder, said that two objects can be resolved if the central maximum of the diffraction pattern of one image is farther away than the primary minimum of the diffraction pattern of the second image. Just as a side note, if you're asked for the criterion, you have to mention that it's the diffraction pattern. So, often we want to ask, all right, are we too far away to resolve the image? So, to do that, we need to consider the relationship between our distance away from two objects and the angular separation between them. So consider this situation right here. Imagine there are two objects, two stars, or two dots on a wall, what have you, a distance d away, and they're separated by a distance s. They form an angle theta a relative to your eyeball over here. And as you get farther and farther away, that angle gets smaller and smaller. Notice this is a small angle, so we can use the small angle approximation, in which sine theta is about equal to theta, which is about equal to little s over d. Now, the Rayleigh criterion says that the two objects can be resolved if the central maximum of one of them is farther away than the primary minimum of the other. So this is the point at which they're just resolved. Now, how far is that distance? The distance when between these two objects in terms of angle, when that's true. We'll take a look at it. It's the same as the distance to that primary minimum to begin with. So the distance between these two peaks is the same as the distance in angle between the primary minimum and the central maximum of either of the two images. As a result, we can just resolve them as long as theta d, defined to be 1.22 lambda over d, which is our equation for the angular distance to the primary minimum for a single slit circular aperture, is less than or equal to theta a. So we need this quantity to be less than theta a, the angular separation in real life. And if it is, then we can resolve them. So as long as this distance is smaller than the separation, the angular separation between the two images, the images meet the Rayleigh criterion and can be resolved. I would encourage you to go through the example problems following this section before moving on in order to practice using the Rayleigh criterion and that single slit diffraction formula to determine whether two images can be resolved.